Hi guys, good morning. Can you hear me? Hello. Yeah, good morning. Yes, good morning guys. Can you hear me? Yeah. So let us start session. Yeah. Let us start. Yes. Java document. So this is yes your document. Yes, in this. Yeah. Yesterday that introduction started. Yesterday introduction started. Yes, actual classes started yesterday. Yes, that introduction. What is software? Yes, what is system software? What is application software? Yeah, these things were discussed here. What is OS discussed? Yes, how OS is working discussed. Next, Java is application software. See, the way introducing it is Java. Just you try to observe that way of introducing it is Java. See here, computer were basically two categories, hardware and software. Computer were basically two categories, hardware and software. So ours is software. We are not a hardware engineers. So ours is software. So start with software. So what is software? Okay. Yes, in software, basically two categories, system software and application software. System software, examples, device drivers, operating systems. Yes, yesterday discussed about these things. What is base and all this. Next, applications. Java is application software. Java is a application software. So that's the reason move to application software. Application software. In application software, there is a front end, back end. Application software, there is a front end, back end. Java comes under front end. So that's the reason move to front end. In front end language and package, Java comes under languages. So that's the reason move to languages. Okay. Yes, in languages, low level language, high level language. So this topic yesterday we discussed. What is low level language? What is high level language? This is discussed. Okay. See here, high level language to the binary code. Yes, binary system understandable language, a binary code. System understandable language. It's a processor understandable language. Okay, binary code. Binary code. Binary code is a processor understandable language. See, compilers and interpreters. See, compilers and interpreters. Compilers and interpreters are used to convert. Yes, compilers and interpreters are used to convert from high level language to low level language, which is binary code, system understandable language. Yes, compiler, interpreter. Yes, today topic is about interpreter and compiler. What's the difference between these two? Okay. So difference between interpreter and compiler. Yes, today topic is about interpreter and compiler. Okay, interpreter versus compiler. Today topic. Yes, interpreter versus compiler. Interpreter versus compiler. What is interpreter? What is compiler? Interpreter versus compiler. Let's see this. Here, try to understand slowly. Yes, I'll explain very clearly. Try to understand it. Okay, one second. Let me have some water. See, first of all, about interpreter. About interpreter. First of all, about interpreter. See, for interpreter, I'm taking Python. Example Python. Python is the interpreter based language. Yes, to explain about interpreter, just I'm taking Python. Next, compiler for this purpose, I'm taking C language. Interpreter versus compiler. So to explain about interpreter, just I'm taking Python. To explain about compiler, taking C language. Let us see first about interpreter. Yes, how interpreter is working here. Yes, see Python example. D drive, mn Python, D drive, mn Python. Yes, here this is a test program is available. See, Python application development. To develop the Python applications, yes, we are using PyCharm. Yes, for big data purpose, we are using Python here. For big data purpose, we are using Python. Okay, so that case we are using PyCharm, PyCharm ID. Real-time applications are PyCharm ID. Using PyCharm ID can develop. Yes, here it's a small program for better understanding purpose. I'm using Notepad. For better understanding, I'm using Notepad now. I'm using Notepad. Okay, so D drive, yes, mn Python. D drive mn Python folder under this test.py. Some Python script file is available. It's a test.py properties. Test.py. .py. .py is the extension. .py. Okay. Yes. Now command prompt. Open CMD. Yes. Search for CMD. Search for CMD. That opens command prompt. Opening command prompt. After that, we should go to this location. D drive mn Python. D drive mn Python. D drive mn Python. So for this D colon, that will take to D drive. D colon, that will take to D drive. Now you can see the contents DER. The contents of D drive. These are the contents of D drive. See here, DER means directory. These all are directories. mn is a directory. mn advanced Java is directory. mn AWS directory. mn C language directory here. mn Hadoop directory. mn Java directory. mn Linux directory. These all are directories. All are directories. Okay, directories. Same thing. See D drive. See mn advanced Java. Yes. mn AWS. mn C lang. Yes. mn Hadoop. mn Java. mn Linux. mn Oracle. mn personal. Yes. Python. Spark. Training. Yes. All these are folders. Folders. Same thing here. Say directory. Directory. Okay. See here. See. Here this is GA. This is called a GA, graphical user interface. It's a GA. GA. Here GA stands for yes, graphical user interface. See non-IT guys, non-IT guys, try to understand it here. GA. So this is called a GA. It's a GA, graphical user interface. Graphical user interface. It's a graphical user interface. Next, this is character interface. This is character user interface. CUI. Yes, CUI. CUI. CUI or CLI also you can say here. So this is yes, character user interface. Character user interface. Okay, CUI. CUI stands for character user interface. Yes. CLI means command line interface. anyone, both are same here. CUI, CLI, both are same. So character user interface or command line interface. Here this is called as character user interface or command line. Anyone you can say here, CUI or CLI, anyone. Yes, GUI. Yeah, this is GUI. Using mouse you can operate. GUI, refresh. So using mouse, double click and open. Use some double click, using mouse you can operate. It's a GUI, graphical user interface. It's user friendly. Next, this is command line interface. Here everything is command. CLS, clear the screen. Yes, all are commands. DR commands, all are commands here. Commands. Okay, no DAR. So here DAR, same thing here, it's a folder. Same thing here, it's a folder. Okay, see here. Yes, directory. Directory is similar to similar to folder. Directory similar to folder. Directory similar to folder. Yes, in GUI, GUI calling as folder. In GUI it's a folder. In GUI calling as folder. Okay. In character interface calling as, yes, character interface calling as directory. In character interface calling as directory. So directory is similar to folder. In GUI it's a folder. In character interface a directory. That's it here. See here now. See MN Rao. Yes, MN Rao AWS, MN Rao Hadoop, MN Rao Java. This all are starting with MN Rao. These are folders. Same thing. See here MN Rao. All are starting with MN Rao. DR means directory. That's it here. But that is directory folder. Both are same. Now, yes, test directory. See. So D drive. 1 second. D drive. In D drive, yes, Python folder. D drive Python folder. Here Python script is available. Some test.py file here. Python script. So how I can go to this location? D drive mn raw Python. How I can go to this location? Yes, D colon C. How I can go to the place? I'm repeating once again. CMD. Open command prompt. After opening command prompt, see here how to open command prompt. CMD, non-IT case. CMD, search for Windows search. Here is a Windows search. Here search for CMD, opening command prompt. After opening command prompt, D colon, that will take to D drive. It's a D drive, C drive, D drive. These are disk partitions. What is C drive? D drive, disk partitions. Okay, in my system drives. See here, system drives, C drive and D drive. C drive is one partition, D drive is one partition. Okay, not D drive. DR, that contents. DR. So all these contents here. Yes, in this here now Python. We should go to Python. So D drive, in D drive, mn raw Python. Mn raw Python, this folder. We should go to this location. How? Yes, in this mn raw Python. This is. We should go to this directory. Yes, direct. How? Change of directory. CD command. CD, change of directory. Mn raw hyphen Python. Okay, change of directory. Changed. CLS. DR. So again output. What is this DR? Anyone idea? What is this command DR? This DR is a directory. That's okay, fine. See, this DR is a directory. This one is directory, no doubts. Yes, what is this DR? This command DR. Yes, about command DR. What is the DR? Command DR. The DR stands for what? DR stands for what? Yes, anyone idea? Yes, already IT background, guys. Already who is having IT background, guys? Try to answer it. What is DR? The DR stands for, yes, disk information report. Okay, so this command DR, the DR stands for disk information report. Means it's giving information about disk here. So DR commands showing contents of disk. Disk contains what? See this. Volume in D drive. Yes, volume in drive D is data. Yes, directory of this one that contains DR means disk information report. The DR stands for disk information report. Disk information report. Disk information report. Next, this DR stands for directory. This DR is directory, no doubt. Now, test.py. Let us open this file here. Test.py. Yes, notepad. Test.notepad. Test.py. Test.py. Yes, open Python script. Yes, open Python script. Okay. Yes, a equal to 10 script here. A equal 10. So memory allocating for is storing 10. Next memory allocating for is storing 20. So a value 10, b value 20. C equal to a plus b calculation. So addition. Yes, next subtraction. Next multiplication. Okay. How this interpreter is? Yes, Python is interpreter based. Python is the interpreter based language. Yes, how it's working here. Let us see how it's working here. How it's working. How it's working. See, Python is now Python interpreter working on test.py. Test.py. Okay, that Python interpreter working on test.py. Okay, so here Python interpreter working on, yes, the test script. Test Python script here. Enter key. See, directly execute it. No errors checking, nothing here. Suppose if it is C programming, yes, first of all, compile check for all the errors. If no errors, yes, if no errors, then program executing. But here no errors checking, directly executing here. Directly executing. So interpreter directly executes. It won't check for errors. It won't check for errors. Okay. Suppose any error is there, what happens here? See this. Now here, suppose here, comma missing. So first error, comma missing. Next here, suppose double quote here. Suppose here bracket missing. Okay. Suppose here this double quote is missing. There are three mistakes in this. Yes, first mistake, next mistake, next. There are three errors in this program. There are three errors. Save, and exit. So next what? No errors checking, directly submission here. See here, I'm using up arrow key to get the previous comments. Up arrow key, down arrow key like this. Yes, it will maintain the history. It will maintain the history here. So I'm using up arrow key. Yes, every time typing command is not necessary. Already user command is a Python test.py. I'm submitting. Yes. So okay, error at line 7. So only one error showed, right? That error coming here, simply stopped here. So next error is not showed. Means it's not working from top to bottom. All the statements, not checking all the statements. So here, so this once reached to this statement here, error message simply stopped here. Once error comes stopped, means it's not checking for next errors. So Python script, how that interpreter is working. Let us see how that interpreter is working. Yes. How that interpreter is working. Yes, how that interpreter is working. See working of interpreter. See working of interpreter is like this. Suppose first statements. Okay. Yes, interpreter based language, not only Python, any interpreter based language, how that interpreter is working. So next statement. Okay. Yes, next statement. There are some statements. There are some statements in this script. Okay. There are some statements like this. Yes, how this interpreter is working here. So interpreter, how interpreter is working. So interpreter, first of all, checking for the first line, first statements. Suppose first statement is correct. Suppose first syntax is correct. Syntax means something like open double quote, close double quote, open bracket, close bracket is some syntax. Every language has its own syntax. Suppose the statement syntax is correct. The statement syntax is correct. Yes, now interpreter converts the statements into binary codes. Yes, zeros ones format. Okay. Yes, if the statement is correct. Yes, if this is checking for the first statement. So first statement correct. Then Yes, interpreter converts this first statement into binary code. Yes, zeros ones format. Zeros ones format here. That binary code given to processor. So processor taking that binary code and generating output simply. Generating output here. That's it here. Okay. Yes. See here. Next coming statement may be right or wrong. Yes, interpreter never think about next coming statements. Interpreter never think about next statements. If that statement is correct, yes, immediately converts into binary code. If statement is correct, immediately converts into binary code and giving output also. So first statement completed, checking completed, execution completed, getting output also completed. Then after finishing all, then goes to second statement. Second statement. So second line checking here. Suppose second statement also correct. Second also correct. Second also correct here. Then same conversion to binary code. Just the conversion to binary code. Next statement also conversion to binary code. That binary code given to processor. So next here generating output here. Generating output. So like this line by line. First line checked and executed. Second line checked then executed. So it's working line by line. So first line checking, then completed. Second line checking, then completed. Next third line checking. Third line checking. Suppose third line, something wrong at third line, simply stops. Error at third line and simply stops. This is working of interpreter. Any error comes, simply interpreter stops. Any error comes, interpreter stops. Any error comes, interpreter stops. That is working of interpreter. Okay. Next, the compiler. How compile is working? Let us see about compiler here. Yes, how compile? Yes, interpreter. This is some Python, some example Python. So Python, some test.py, some Python script expand here. So this is okay. See this now here. See, let's see here. See Python script in this first statement, next statement. Yes, here this statement error message simply stopped here. Means it's not checking next coming statements. Still errors are there. It's not checked. Only this statement checked. No correction of this error. Seventh line. See error at seventh line, right? See output. 1 second. Save. See, I'm submitting directly. Yes, this Python script is submitting directly, executing directly. Seventh line error. Yes, set the statement error. Now let us correct that mistake here. So comma, mistake is comma. Okay, save, then exit. Now run this here, run it. Yes, next error, right? That means showing only one error at a time. Actually, one more error is there here, right? So, but it's not showing only one error showing. Only seventh line error, 11th line error is not shown. Now only one error. This is only one. So 11th line. Let us correct that mistake here. So 11th line. Mean this is the error. So here bracket missing. Save. Control yes, save and exit. Now submit again here. Submit. Yes. Next error. So once error coming, simply stopping. So by this interpreter shows only one error. Yes, not only Python interpreter, any interpreter shows only one error. So only one error. So next error. Yes, next error, double quotation. So this closing, double quotation. Okay, next error, right? Yes, now run it here. Run it. Yes. Only one error. This is yes, no errors executed. Okay. So how interpreter working here? See this, checking first line, no error is giving output. Checking next line, no error, giving output. Checking next line, something wrong, simply stops. So interpreter shows only one error. Okay. Suppose if it is compiler, yes, how compile is working? Let us say about compiler here. How compile is working? Let us say about compiler. Yes, how compiler working here? Compiler. Suppose for this compiler, C language. Let us take C language. Test.c. Yes, how C program? Yes, how compile is working here? How compile is working here? C compiler. Yes, compiler checking for the first statement. Suppose first statement is correct. Even it's correct, it won't convert into binary code. No, it won't convert into binary code. It won't convert into binary code. Suppose second statement also correct. Second statement also correct. Even correct, it won't convert into binary code. No, it won't convert into binary code. 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 Okay. So checking for next statements. Yes, next statement also correct. Suppose next statement something wrong here. Something wrong. Next statement something wrong. Error at third line. Next statement something wrong here. Error at some line. Error at third line. Error at third line. Okay. Yes, after that, checking for next statements. Checking for next statements. Checking for next support. Next statement is correct. Then checking for next statements. Checking for next statements. So like this here. Yes, even no error, it won't convert into binary code. So checking all the statements from top to bottom. Checking all the statements from top to bottom. Checking all the statements from top to bottom. Suppose next error. Something wrong here. Next error. So next error. Something wrong here. So next like this. It's like this top to bottom. Compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. It checks whole program from top to bottom and shows all the errors. Next error, next error, and next error. We are checking all the statement from top to bottom, shows all the errors in the program. This is compiler working here. Compiler checks whole program from top to bottom. Compiler, compiler checks whole program from top to bottom and shows all the errors. So first error, next error, next error. See, interpreter is only one error, right? Interpreter is only one error. Interpreter is only one error. But compile is all the errors from top to bottom. Compile is showing all the errors from top to bottom. Compile is showing all the errors from top to bottom. Okay. Yes. Suppose, yes, errors, correction of all the errors. Correction of all the errors. Next, the correction of all the errors. After correction, no recompilation. Yes, when recompiled, yes, this statement no error, correct. Yes, next statement. This statement also no error, correct. So everything is correct from top to bottom. Everything is correct from top to bottom. Yes, everything is correct from top to bottom. Then what happens here? Yes, everything is correct. Then what happens here? Get that case here. Now it opens another file. If everything is fine, it opens another file. Yes, this is test.c program. Test.c program, your C program, that C program. For example, test.c. Some C program. Let me open C program. Here, this is C program. C program. C wide main. Yes, int A, int B, int C. The three variables declared. Enter first number, enter second number. Yes, same that like a Python scripting here. C equal to A plus B addition. C equal to A minus B subtraction here. C equal to A and B multiplication. Now all compilation. Compiled success, no error. No run it here. Yes, enter first number 10, second number 20. Okay, fine. Yes, how this program is working. Yes, in this C program. Okay. Yes, program to add, subtract, and multiply two numbers. Now, let us do some mistakes here. Here some mistakes. Suppose here that semicolon missing. Suppose here bracket missing. Okay. Suppose scanf here comma missing. Comma missing. Okay. Suppose here, yes, scanf here double quotation missing. Suppose printf, in printf, yes, this double quotation missing. Okay, there are some missing statements here. Suppose this printf bracket missing. Okay. Suppose here semicolon missing. There are some mistakes here. Suppose get ch, this bracket is missing. Now let us compile it. Yes, Alt C for compilation. Now just only compilation. Compile option, compile enter key. That compile option enter key is compiled error message. How many errors here? There are 11 errors. There are 11 errors. 11 errors, right? 11 errors. Press any key. There are 11 errors. 11 errors. Press any key. Yes. Now this error. Next error. See. Look at the bottom. Look at the bottom. 14th line error. 18th line error, 22nd line error, 25th line error. Yes. See 29th line error. Yes. 31 line. Yes. Down arrow key. Down arrow key. I'm pressing down arrow key. Up arrow key. Up arrow key. Down arrow key. 14th line error. 18th line error. 22nd line error. 25th line error. 29th. 31. 33. 38. Yes, like this. 40th line like this. All the errors from top to bottom. Compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. No, correct that mistakes. Here semicolon, correcting mistakes. Yes, here bracket missing here. Next here comma missing. Okay. Next here scanf here. Yes, double quotation missing here. Okay. Next here. Yes. Next here bracket missing. Yes. Now let us recompile here. Yes. Alt C. Let us recompile. Yes, still some more errors. Four errors. Four errors. Some more errors. See all see. Still errors are there. Errors. No correct that mistakes. Yes, here double quotation missing. So the statement missing here. So next here printf. Yes, here printf. Here. Yes, this bracket missing. Here, this bracket missing. Okay, right? Next here semicolon missing. Okay. Yes, now compile. All see compile. Compile success. Success, no error. If no error, then what happens? If no error, then what happens? Let us see. Yes, if no error, now we should run the program. If no error, now run it here. Run. Yes, first number 10, second number 20. Yes, addition, subtraction, multiplication. Right. So what is happening? If no error, what is happening? Let us see. Yes, let us go to backend. C drive. In C drive, Turbo C install the Turbo C. Yes, it's a Turbo C. This Turbo C software. Turbo C software. Turbo software installed in C drive. C drive. Yes, C drive. C drive. Here TC folder. TC folder in this bin folder. In bin folder, this is the location. Yes, that's yes. What is name of the program file here? Math.cpp. C plus CPP means C plus plus. CPP means C plus plus. Both compilers are same. C plus plus and C language both are same here. In C plus plus you can write C program. In C plus plus compile you can write C program. Both are same. CPP math.cpp. So backend math.cpp. Math.cpp. Here math.cpp. See, this is math.cpp. Okay, math.cpp. See backend, you can open that file here. Edit. See, this is that math.cpp file here. Backend. Backend. Okay. Yes. 1 second. See here. See math. Yes, math.cpp. Okay. So by this name math.cpp, right? No. I'm compiling. Compile. After compilation, next time running here. See, when I'm running here, yes, run it. Yes, here, one file generated backend. One file generated that math application, that file, application file means applications exe file. One exe file generated. One exe file generated. Now what happens here? Yes, compiler checking from top to bottom. Compiler checking from top to bottom. If no errors, it opens another file. It opens another file. After opening another file, this all the statement top to bottom converts into binary code. Zeros ones formats. Zeros ones formats. All the statements converts into binary format. Zeros ones formats. So zeros one binary format. Binary format write to another file. The zeros ones format. Zeros ones format write into another file. Write into another file. That this file is called as exe file. This file is called as exe file. Okay, that's exe file generation. Exe means executable file. Exe file means executable file. Okay, exe file generates. Exe file generates here. See that exe file. That exe file. See this. Math.exe file generated. Yes, here no error. Okay, so first of all, math.exe file generated. That exe file. .exe file generated. Math.exe file generated. After generating exe file, that exe file is given to processor. that exe file given to processor. So processor taking that exe file, then executing, generating output at a time. At a time executing the top to bottom and giving output. That is. So this is interpreter and compiler difference here. Okay, exe file given to processor, generating output. Okay, so this is C programming. Okay, see in Linux you can see clearly, very clearly. Okay, Linux. See, suppose in Linux C programming, Linux based C programming. Yes, there you can see very clearly. Yes, in Linux manually everything that yes you can understand very clearly what is happening. You can understand very clearly. So let us see in Linux also. Linux how C program is working. Okay, so you can how compile is working here. Compiler checks the whole program from top to bottom. Compiler checks whole program from top to bottom, checking all these statements here. If no errors, generating one exe file. This whole code, that C program code, whole code converts in binary format like this. Binary format is understandable language. And write to this result file. That result file is called exe file. One exe file generates, then executing here. Exe generate executing, right? Now waiting for our input. That executing. First number 10, second number 20. Yes, output. So it will generate on exe file, that exe file executes. That exe file given to processor, generating output. That's it. That's it here. Okay, see Linux. Now in Linux you can see manually here. Yes, very clear understanding Linux base. Okay. Yes, this is IDE. In IDE maybe little bit confusion, but when come to Linux base here, yes, very easy to understand. Practically you can see. Yes, manual development. This completely IDE is it here. Integrated development environment. Okay, behind of IDE, that exe file created. Now in Linux, we should create exe file. If it is Linux base, see Linux base. See, you guys don't think about Linux commands. Don't worry. Topic is compiler. Topic is compiler. Don't think about Linux. Okay. See, Linux also you can develop the Java applications. See, it's Eclipse. It's Eclipse installed in Linux base. I'm using Linux also for Java applications. Okay. Yes, here cd change of directory. See, Windows OS cd command is there. Same here also. Change of directory. Doesn't work in directory ls. Its contents here. 1 second. Yes. See. Yes, test.c. gedit. Notepad. Gedit is like a Windows notepad. Gedit test.c. That C program file open here. Yes, this is a C program file. C program, same. Yes, A equal to B equal 20. Yes, C equal to A plus B. Addition, subtraction, and multiplication. Okay. Save it. Suppose here are same. Suppose some semicolon missing here. Some comma missing here. Yes, here some semicolon missing here. Okay. Suppose double quotation missing. Some statements. Save. Save and close. Now compiling this C program. GCC -C test.c. Just we are compiling manually. Okay. Yes, manually we are compiling. GCC means C language compiler. GCC, C language compiler. C language is compiling. Yes, see that all the errors from top to bottom. Compiler shows all the errors from top to bottom. See 10th line error, 12th line error, 14th line error, 18th line error, 22nd line error, and 23rd line error. All the errors from top to bottom. Compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. Okay, now let us correct all the errors here. So this is semicolon here. Okay, yes, next here it's a comma. Yes, here semicolon. Yes, here some double quotation missing. Save and recompile. Save and recompile. Yes, save and recompile. Yes, no error. No error. Yes, no error. Some test.to file generated. Test.to file generated. Yes, after that, now we should convert into exe file. GCC -o. Yes, exe result name is some project is a exe name. Test.to. Test. Yes, exe file created. See, project is a exe file. That result exe is project. Now this project exe file you have to run it here. You have to run it here. That's it. Okay, this is more clear, right? See, first it compiled. After compilation, one test .to file generated. .to means object file generated. After that, next step we have converted into exe file. So yes, GCC is C language compile generating exe file. The project exe file generated. No running here. So output like this, right? That exe file generated. Project exe. That exe file. Yes, this name can be anyone. Suppose exe file. Suppose mn raw. Mn raw that exe file. Yes. ls dot slash mn raw. Run it here. Mn raw. Yes. Addition, subtraction, modification. Any name. That exe name can be any name here. The result name. So Durga exe name. Durga. Yes, Durga. Yes, dot slash Durga. Yes, 1 second. ls. That Durga, right? That exe file. Okay, running that exe project exe file. Yes, exe file. So this, let me show this exe file. Gedit project exe file. Project exe file. Opening that exe file. Opening that exe file. It's opening. Just it will take a little bit time. Yes, this is exe file. Serial funds format. It's a system understandable language. It's a machine language. This is machine language. That machine language code. Okay. Yes, it's a processor understandable language. It's a processor understandable language. This is exe file. That exe file generated. After that exe file executing. That exe file executing. That's it. Okay. So what happens here? Compiler. If it is compiler, what happens? Compiler checks the whole program from top to bottom. If no errors, generating exe file. That exe file given to processor generating output finally. Okay, so at a time executing whole program from top to bottom, exe file generating and executing that. Now, what's the difference between compiler and interpreter? Let us see the difference. Let us compare this. You can understand clearly. Now let us compare this. Okay. Yes. Just the points wise. Let us compare this. Let us compare. Yes. Interpreter. Interpreter. Yes. Interpreter. Interpreter. Yes. Compiler. Interpreter and 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 compiler. See how interpreter is working. See interpreter and compiler. See interpreter. Yes. First difference. Yes. It checks the codes. Interpreter. It checks the code. It checks the codes line by line. It checks the code line by line. Interpreter. It checks the code. It checks the code line by line. Line by line. Yes. Compiler. Yes. It checks codes from top to bottom. From top to bottom. All the whole code, whole program from top to bottom. Means whole program. It checks whole. Yes, whole program. Checks whole program. It checks whole program. Okay, complete codes. Okay. See, interpreter, first difference. Interpreter checks the code line by line. Okay. But compiler, it checks the code from top to bottom. It checks the code from top to bottom. Top to bottom. Yes. Next difference. Next difference here. See, it generates output too. Generates output line by line. Even output are line by line. Checking first statement if correct, generating output. Next statement checking, generating output. So it's line by line output. Output are line by line. Yes, in case of compiler, what happens here? Exe file created. See that exe file created, right? That output at a time getting here. Exe file created and generating output, right? So at a time output here. At a time. Yes, at a time output. So here generating output at a time. Okay, right? Yes, next difference. See, interpreter only one error, right? Interpreter showing only one error. That interpreter showing only one error. Any error comes simply stops. Okay, interpreter is only one error. See that interpreter, only one error. Any error comes simply stops. But compiler shows all the errors from top to bottom. Compiler shows all the errors from top to bottom. So next, yes, it shows only one error. It shows only one error. Compiler, yes, it shows all the errors. It shows Yes, all the errors from top to bottom, from top to bottom, from top to bottom, from top to bottom. Okay. Yes, it shows only one error. Interpreter is only one error, but compiler it shows all the errors from top to bottom. Yes, compiler shows it shows all the errors from top to bottom. Okay. Next, most important difference. Most important difference is exe file. See, in case of compiler, there is no second file, right? See this. Program directly executed. Program directly executed. If the source program executed directly, but in case of compiler, what happened? The project exe file generated. One exe file, the result exe. The project exe file generated, right? The project exe file executed. Yes, here also. Yes, Windows based. Here also, some exe file, math.exe file. See that math.exe file generated and executed. So here exe file. Yes, interpret directly executing, no exe file. Directly script executing directly. Okay, that's source. This is called source code. Yes, this code. So our program is called a source code. This is called a source. This program called a source code. Okay. Yes. See this program called a source code. Our English program. What are the program we are writing in English? Our program called a source. It's a source code. This is source code. This is source code. This is called a source code. Suppose one more example. One more example. Java. Suppose Java. Test.java. Yeah, this is also source. This is called a source code. This is called a source code. This is called a source code. Okay, fine. Now, in case of compiler, what happens here? See, in case of interpreter, source code directly executing the test.py file. But in case of compiler, exe file generating, that exe file executes. Okay, yeah, this is the main difference. Interpreter, it does not generate exe file. It does not generate exe file. Yes, compiler, it generates exe file. It generates exe file. Okay, yes. So interpreter, it does not generate exe file. Compiler, it generates exe file. It generates exe file, right? Yes, next difference. See, interpreter based. See that source code executing directly. Yes, it executes source code directly here. Yes, it executes source code. It executes source code means your program. It executes source code directly. Source code directly here. Yes, what happens? Compiler. First exe creating. That exe executing, right? Exe executing. That exe file executing. Okay. Yes. It executes exe file. Yes, it executes exe file. It executes exe file. Okay. Yes. This is fourth one is main difference. Exe file. Yes, interpreter compiler main difference is exe. Interpreter and compiler main difference is exe file. Main difference is exe file. Main difference is exe file. Okay. Yes, it executes source code directly. Yes, compiler it executes exe file. Compiler it executes exe file. Okay. Yes, after this next statement, next difference here. Yes, interpreter based language called as scripting languages. These are scripting languages. These are scripting languages. Scripting languages. See, interpreter based languages are scripting languages. These are called as programming languages. Programming languages. Okay. So you can scripting language and programming language. Scripting language. Scripting means that can be modified anytime. Scripting means that can be modified anytime here. See Python script. Open that and modify. Suppose I don't want multiplication. I can remove it here. Save and running directly here. Right? Running directly. Suppose I want to add it again here. Yes, I can add it. Yes. Save. Okay, this is yes script that can be modified anytime here. Yes, when come to programming. Yes, I want to modify. First of all, yes, I should modify the test.c. After modification, I have to rebuild. So getting project exe file. Once you get the exe, that exe file cannot be modified. Exe file cannot modify. This is a process. Okay, if it is compiler based, you cannot write program. Yes, programming you cannot modify directly. Programming, if you want to modify it here, first of all, you have to modify the source code. After modification, you have to rebuild it, means recompilation and regeneration of exe. So all these steps you have to follow. So directly cannot modify. So cannot be modified. That is programming. Okay. Yes, scripting and programming different. Scripting anytime can be modified, but programming cannot be modified. Scripting can be modified anytime, but programming language, that result exe file you cannot modify. Programming language here is exe file. That exe file cannot modify. Interpreter based language no exe. Script directly can modify. Script means anytime it can be modified. Script means anytime can be modified. That is script. Okay. Yes. Next. Yes. Scripting language examples. Examples. Best example Python. Python scripting language. Next HTML. Next JavaScript. JavaScript is not a Java. See Python, for this Python interpreter, HTML is a browser understandable language. Hypertext markup language. Hypertext markup language. Okay. Yes, the HTML. It's a browser understandable language. It's a browser understand. Browser is the interpreter. Browser is an interpreter for the HTML. Okay. Yes, JavaScript. JavaScript is not a Java. Java is different. JavaScript is different here. JavaScript is a browser understandable language. Java is a JVM understandable language. JavaScript is different. Java is different. So JavaScript. Yes. Next. Yes, Perl scripting. Next, PHP scripting. So they are scripting language. Programming language examples. C language. Yes. Next, C++. Next, .NET. That's the program. .NET C Sharp. Or C Sharp. So these are interpreter based language, programming language examples here. Scripting language examples. Programming language examples. Okay. See, interpreter based language don't have exe file. See, interpreter. Yes, interpreter. Yes, interpreter based language. Don't have exe file. Interpreter based language don't have exe file. Here everything is exe file. Yes, finally getting one exe file or running exe file. Yes, always using exe file. Okay. Next, interpreter based language. It's a yes. Of course, Ruby also scripting language. Ruby. Okay. Yes. Here interpreter based language, scripting language. Yes, it's a scripting language. Yes, it can be modified anytime. That means open source. Yes, it's an open source programming. Open source programming. Yes, it's an open source. Yes, it can be modified anytime. See, if we able to modify the code anytime, that is called as open source. If we able to modify any time, that is called as open source. Yes, it's an open source. It can be modified. It can be modified anytime. Yes, at any time. At any point of time, you can modify it. Okay. Yes, it's an open source. Here. Yes, it can be modified. Yes, at any point of time. Okay. Yes, it cannot be modified. It's not an open source. It's not an open source. It's not an open source. It's exe file concept. Yes, exe here. Exe is the right. Exe can't understand. You can't do anything. Exe based completely. Complete exe based. You can't do anything. So it's not an open source. Okay, but this is open source. So this is difference between interpreter and compiler. See, interpreter checks the code line by line. Yes, compiler from top to bottom. Whole program. Okay, interpreter is line by line. Compiler is whole code from top to bottom. Yes, output are line by line. Compiler at a time generating output. That exe for executing, generating at a time output here. Yes, interpreter only one error. Compiler shows all the errors. See, interpreter does not generate exe file. Yes, here compiler generates exe file. Okay, interpreter it executes source code directly. executing source code directly. Yes, compiler, it executes exe file. Yes, interpreter based language called a scripting language. Interpreter based called a scripting languages. Interpreter based called a scripting language. Yes, compiler based called as programming languages. Okay, examples. Interpreter based examples, compiler examples. Yes, interpreter based language don't have exe file. Compiler, everything is exe file. See, main difference is exe file. Interpreter based language no exe file. Compiler based language exe file. So this is difference between interpreter and compiler. That's it. Fine. Fine. Well and good. Now here some doubt too. Maybe getting some doubt. Here this trainer, this MN Rao, yes, this trainer is explaining about compile, interpreter, C, C++, various kind of things. But he's not talking about Java. Yes, maybe getting this doubt. He's not talking about Java. He's talking about all the other things. Why not talking about Java? Maybe getting this doubt here. Okay, now Java, yes, is it interpreter based or compiler based? Now let us start Java here. Java, yes, what is Java here? Java, yes, is it interpreter based or compiler based? Yes, anyone already idea? Yes, Java, what is interpreter? Yes, sorry. Java, is it interpreter based or compiler based? Any idea? Yes, Java, maybe already in your engineering got your Java here. Maybe learn some Java. Yes, what is Java? Is it interpreter based or compiler based? Java, interpreter based or compiler based? Yes, interpreter based or compiler based? Yes, most of the guys saying that compiler based. Yes, Arham. Yes, Sahajada, compiler based. Pradeep, compiler based. Akash, compiler based. Pratap Reddy, compiler based. Shivatesha, compiler based. Bharat, compiler based. Yes, everyone saying that compiler based. Yeah, let me explain. I'll explain, you decide it. Okay. First, I'll explain about Java. Just let me explain about Java. Then finally you decide it here. Is it compiler based or interpreter based? Just you decide it here. Yes. See, except Java, in other languages, what happens here? Except Java in other languages, first of all, your source code. Yeah, this is called a source code. This is your English language. That English language program is a source code. Yeah, this is source code. This is source code. Source code. Okay. See, Java program. This is source code. It's called a source code. That English language. That code is a source code. Okay. Source code converts into binary code. Binary code. Source code converts into binary code. Yes, source code converts into binary code. Here, this is by either compiler or interpreter. Yes, either interpreter or compiler. Either interpreter or compiler. Only one thing. Either interpreter or compiler converts from source code to binary code. Binary code means zeros ones format, right? Binary code means zeros ones format. Binary code, system understandable language, zeros ones format. Source code means that English language code converts into binary code, system understandable language. System understandable. That code given to processor. Processor. Yes, processor taking that code, generating out. That is what is happening other language. In other language. Now, Java. Yes, in Java, what happens here? Let us in Java. Yes, in Java, what happens in Java here? Java, what happens here? See. So, first of all, Java source codes. Yes, given to Java compiler. Yes, that compiler converts Java source code. Yeah, let me show Java also. Java D drive test folder. Here test.java file is available. Some test.java file is available. D drive test folder. D drive. Okay. Now let us mn drop. Let us back to D drive. CD backslash. Let me take the starting location. D drive. CD backslash. D here. Now, so test folder. This is D drive test folder. See D drive test folder. cd test sorry cd test folder, cls here see test.java file. Okay, cls dir, yes, here they say test.java file. See the test.java file, test.java file, test.java file. One second, test.java file. Let us open that file here. Notepad. Yes, using notepad, using notepad. Of course, Java application we can develop using Eclipse. See, our daily class I'll be using Eclipse. For understanding purpose today I'm using some notepad. For understanding purpose simply I'm using notepad. Actually, yes, in real time our daily classes I'll be using Eclipse. I'll be using Eclipse. Okay, now notepad test.java, test.java. Yes, open. Okay, open here. Yes, here. Okay, one second. System dot out dot, yes, println, yes, hello world, hello world, hello world. Yes, save save and exit, save and exit here, save and exit here. See test.java 10:23 am. Yes, third, fifth, and just now modified. This is date and time of last modification. Just now modified. Now compiling Java program for the Java compiler Java C test.java. Compiles the result is test.plus. C program compilation, after compilation generating one exe file. But in Java it's a dot class, not exe file. C language .exe, but is a dot class. Dot class file is not exe file. So dot class file is different, exe file is different. Exe file contains binary code, system understandable language, but dot class contains byte code. What happens here? What happens here? First is source code converts into byte code. Source code converts into byte code. But that byte code next level converts into binary code. Binary code. So two stages. So this binary code given to processor. So processor generating output here. Okay. Now see this. Next Java compile here. After compile result is dot class is a byte code. Now this byte code executing here. Tested. Yes. Yes, here this is Java test. Now byte code converting to binary code, then executing here. Okay, what happens here in Java? There are two stages here. See, other language only one step. Other languages only one step, but Java two stages. So first one, source code to byte code. Yes, byte code to binary code. There are two stages. Yes, why byte code introduced in Java? In Java from intermediate code byte code introduced. So why this byte code introduced here? To make the Java as independent platform. To make the Java as independent platform, byte codes are introduced here. So what's the purpose of byte code introducing here? To make the Java as independent platform. Yes, we'll discuss. How is Java made as independent platform? Next topic. After finishing, next immediate topic is independent platform topic. Okay. Source code to byte codes. Yes, source code to byte code to binary codes. Now source code to byte codes. We will convert. Source code to byte codes. Yes, source code to byte codes. Yes, this is by the Java compiler. This is by the Java compiler. This part is by the Java compiler. Java compiler will do this. Java compiler. Next, byte code to binary code. We will do this here. Byte code. Next step, byte code to binary code. This is by the Java interpreter. Java interpreter. Okay. So this step, source code to byte code by the Java compiler. Source code to byte code by the Java compiler. Byte code to binary code by the Java interpreter. That's it here. Now what is happening here? See. So first, yes, test.java. Test.java. Test.java is a source code. It's a source code. Test.java is a source code. It's a source code. Test.java. Yes, it's a source code. Test.java is a source code. Okay, the source code given to Java compiler, Java C. See here, see this. Yes, Java C means Java compiler tester Java. Okay, now it's compiling Java C means Java compiler. Yes, compiling tester Java. So tester Java given to Java C compiler. C tester Java source code given to Java C compiler. Now Java compiler, Java C Java compiler checking for all the errors. If no errors, generating one dot class file. Generating one dot class. This is bytecode file. It's a bytecode. This is bytecode. This is bytecode. So generating bytecodes. Yes, bytecodes generated. After generating dot class here. Okay. So bytecode generated, dot class file generated, dot class file. Yes, at what time? 10:27 a.m. So 3rd Feb 10:27 a.m. At this time dot class file generated. Now this dot class file, yes, executing with interpreter. Now this is the interpreter. Dot class, yes, taken by the interpreter. See, this is a dot class bytecode file taken by the interpreter. Bytecode taken by the interpreter. Okay. Now bytecodes, the dot class file taken by the Java interpreter. Java interpreter. Yes, it's the interpreter here. So this is interpreter. So this step by the interpreter. See interpreter. See interpreter, that dot class file means bytecode file taken by the interpreter. Interpreter. Yes. So the bytecode file given to Java interpreter. Now Java interpreter converts that bytecode to binary code. Yes, converts bytecode to binary code. That binary code given to processor, then finally generating outputs. That's it. So what is happening here? Yes, in Java errors checking by the compiler. Java errors checking by the compiler. Okay. Yes, in Java errors checking by the compiler. Yes, in Java errors checking by the compiler. Next, program execution. Java program. Yes, program execution means runtime. Program execution means runtime. Who is running program? Interpreter. Runtime. Program execution by the interpreter. Interpreter, right? The program execution by the interpreter. Okay. So in Java errors checking by the compiler. Yes, program execution by the interpreter. So finally getting result here. Now tell me. Now Java depends on what? Java, yes, depends. Java depends on what? Yes. Is it compiler based? Is it compiler based? Compiler based or interpreter based? Interpreter based. Yes, is it compiler based? Interpreter based or both? That is the question. Yes, now tell me. As per my explanation here, yes, Java, is it compiler based or interpreter based? Both here. Yes, is it compiler based or interpreter based or both here? Yes, it's in both. So Java depends on, see, Java, yes, Java depends on yes, Java depends on both compiler, yes, Java depends on both compiler as well interpreter. Yes, as well interpreter. That's it. Okay, Java depends on both. This answer. Okay, Java, is it compiler based or interpreter based? Yes, it's a both. Okay, both are involving here. Two things are involving. So first, see this. First, compiler involving. Okay, CLS, clear screen. So what is happening? We are writing program using Notepad. See, using Notepad we are writing. Of writing program, what is next? Compiling. So compiler involving errors checking by the compiler. Yes, error checked. After that, next program execution by the interpreter. That's it. So both are involving. Yes, if it is yes Python, what happens here? Directly that interpreter executes. Suppose C language, only compiler, no interpreter. Python, only interpreter, no compiler. But Java, both. Java depends on both interpreter as well as compiler here. So Java depends on both, yes, involving both compile as well as interpreter here, both involving both. Okay, now yes, one second. Yes, some question for you guys. No, only Java is the interpreter. Java is a special case. No other language based on both here. Only Java is a special case. Java is a special case. Okay. For Java next generation Scala. Scala is also same. Compiler as well interpreter based both here. Scala both. Compiler, interpreter based. Scala is a next generation of Java. Scala programming. Scala. This is next generation of Java. Same like a Java. Scala programming, same like a Java. Okay, Scala programming is very easy compared to Java. In Scala, many libraries, predefined libraries available. Scala programming is very easy compared to Java. Okay, yes. Java depends on both the compiler as well as interpreter. Here's some question for you guys. Some question. First, to try to understand it here. Some 8 points. In 8 points. See, interpreter compile difference 8 points. Interpreter based language don't have exe file. See, any language runtime is an interpreter based. Runtime is program execution. Yes, runtime is execution. Runtime is program running. Any language runtime is an interpreter based language. Interpreter based here. Any language runtime is interpreter based. No exe file. No exe file concepts. Yes, no exe file. No executable file here. Any language runtime is interpreter based. No exe file. No exe file. Now tell me, question is yes. Can we create exe file in Java? Can we create exe file in Java? Okay. Yes. Question is can we create exe file in Java? Or question, yes, is there any exe file concept in Java? Is there any exe file concept in Java? Is there any exe file concept in Java? Tell me, guys. Yes, your answer. Yes, as per your understanding here. Answer yes or no. Yes, can we create exe file in Java? See, simply the statement explained very clearly. In this statement explained very clearly. Any language runtime is interpreter based. No exe file. See, Java runtime is an interpreter based. Java program execution by the interpreter here. Java error checking by the compiler here. Okay, program execution by the interpreter. Java runtime is interpreter based. Java runtime is interpreter based. See, any language runtime is an interpreter based no exe file. Now question is, can we create exe file in Java? Can we create exe file in Java? Is there an exe file concept in Java? Yes, try to understand what I'm saying here. Dot class file is not exe file. Dot class file is different. Exe file is different. Dot class is not exe file. Dot class file is different. Exe file is different. Yes, maybe. Yes, in your college, your trainer maybe explained dot class is exe. No, wrong. Exe file is different. Dot class entirely different. Nowhere matching. Yes, I'll explain what is exe file, what is dot class file. The differences we'll discuss. Exe file and dot class file difference. Exe file dot class. There's a lot of difference. There's a lot of difference between exe file dot class file. Dot class file is not exe file. Wrong. Dot class file is not exe file. Dot class file is not exe file. See, very simple point already explained. Why you struggling? Very simple point already explained here. Why you struggling that much here? See, any language runtime is interpreter based, then no exe file. See this point, try to understand this. Any language runtime. Runtime is program execution by the interpreter, no exe file. See Java program execution by the interpreter. Java program execution by the interpreter. So Java runtime is interpreter based. Now you answer this question. Simple, simple. See, already explained, right? This point already explained here. Yes. See, Java program, yes, runtime. Runtime is interpreter based. If runtime is interpreter based, any language runtime is interpreter based. Runtime is interpreter based. No exe file. Java runtime is interpreter based. Yes, if it is interpreter based, yes. Is there any exe file? Yes, no exe file in Java. You can't create. Can we create exe file in Java? No, you can't create. See here. Yes, in this process, what is the first step here? Notepad. Yes, Notepad test.java. So test.java program developed. Okay, after that, yes, Java C compiled. So Java C compiled, generated dot class file. Generate dot class file. Dot class Java test dot yes, Java test. Java test running. Yes, in this process, have you observed any exe file? Tell me. In this process, have you observed any exe file? Hello. In this process, have you observed any exe file? Dot Java is there, dot class is there, dot exe file. Have you observed any dot exe file? Hello, hello, what's happening? Yes, in this process, have you observed any exe file? No exe file, no very exe file here, no exe file. Yeah, there is no exe file concept in Java. Java don't have exe file concept. Okay, no exe file. Java don't have. Yes, Java don't have exe file. Java don't have exe file. Yes, in Java, see in Java, yes, everything is a dot class file. Everything is a dot class file. See, dot class file, yes, is not an exe file. Dot class file is not an exe file. Dot class is an exe file here. Yes, dot class file is not an exe file. See, exe file. What is exe file? Exe file is a binary code file. Exe file is a binary code file. Binary code file. Yes, it's a system understandable language. It's a system understandable. It's a system understandable language. It's a system understandable language. Okay. So exe file. Exe file is a binary code file. Zeros ones format. It's a system understandable language. It's a system understandable language. What is dot class file? Dot class. See, dot class is a bytecode file. It's not a system understandable. Okay. Dot class is a bytecode file. Bytecode file. Yes, it is a JVM understandable language. JVM not computer understandable. JVM understandable language. JVM understandable language. JVM understandable language. JVM understandable language. Yes. So more about exe file dot class for differences tomorrow topic. Exe file dot class. Yes, tomorrow topic. Yeah, these features independent of platform portability. Yeah, these features concluding tomorrow. Tomorrow I'll be explaining about all these features here. So independent of platform. That time, yes, we'll discuss about exe file dot class file differences. Dot class file is not a exe file. Dot class is entirely different from exe file. Lot of differences are there. Many differences. I'll explain clearly. Okay. See here. My knowledge is different. Others' knowledge different. My experience different here. Others' experience different here. Most of the Java trainers says the dot class file is exe file. 100% wrong. 100% wrong. They are wrong here. Yes, most of the Java trainers, most of the websites simply says that dot class file is exe file. No, wrong. Yes, how it is wrong, I'll prove it. In tomorrow class, I'll prove it. Dot class is entirely different from dot exe file. Exe file is different, dot class is, both are not same here. In Java, there is no concept of exe file. No concept of exe file in Java here. Java don't have exe file. In Java, everything is dot class file here. Yes, no concept of exe file in Java here. No concept. No concept of exe file. No concept of exe file. Java is independent of platform. Suppose if the exe file concept is said, it's a OS dependent. Exe file is OS dependent, but Java is what independent of OS. Java is independent of OS because Java no exe file. Java no exe file. Java is not exe based. See, any language exe based compulsory OS dependent, but Java is not exe based. Java is not exe based. That's the reason it's an independent platform. Yes, tomorrow topic. Tomorrow topic here. How exe file is working, how dot class file is working. Yes, how dot class file made us independent platform. In tomorrow topic, that will be clear here. Very clearly explained in tomorrow topic. Tomorrow is very interesting topic. Yes, the tomorrow class. Tomorrow class independent platform. How would Java made us independent platform? That explains very interesting class. Yes, compared to all the yes last 3-4 classes, compared to that, tomorrow class is very interesting class. Okay. Yes, you guys you may be joining into batch or not, but don't do tomorrow. Don't miss it. Okay. Yes, tomorrow don't miss it here. Joining is secondary. Joining into my batch is secondary here. Okay. Tomorrow don't miss the class. Okay, you can attend it free of cost, no worry. Tomorrow class also you can attend free of cost. Then after you decide it. You decide it. But tomorrow class is very important. Okay. Yeah, that's all for today. Yes. Any doubts? Any doubts? I think you guys not expected this much of yes introduction. This kind of introduction, I think no one expected. Started from basics and each and every point explained very clearly. Okay, even non-IT guys also can understand. Even IT guys are some unknown facts. Yes, here I am explaining some unknown facts here. See here. See today topic interpreter and compiler. This topic search in the internet, search in the Google. No website will give this much of information between interpreter and compiler, the differences. No trainer will explain. Yes, no website will give this much of information because of my experience, embedded C experience. I have very good experience embedded C, also not in Java. Very good experience embedded C. Embedded C. I have Linux based embedded C. So because of that reason, I'm able to explain practically everything here. Okay. Yeah. That's all. That's all for today. Yes. See, 1 second. How to access your documentation and all this? How to access your documentation and recordings? Yes, go to Google. Yes, log into your Gmail. Of log into Gmail, go to Google Drive. Here there is a drive. Open Drive. Open Google Drive. Okay. So open Google Drive. After opening Google Drive here, share it with me. After opening Google Drive, share it with me. Share it with me. Here you can see. Share it with me. Yes, of course Java. This is documentation. This all this documentation. You can see like this. Share it with me. of course Java folder. You can see in your Google Drive. In your Google Drive, you can see. This is all the documentation. Okay, next. Yes, of see 915 AM folder. This folder. of 915 folder. Open this folder. You can say recordings. That last 3 recordings. Today recording also I'll upload. Today recording also I'll upload. Okay. Yes. Yes. In your batch, almost all everyone paid. Yes, I think around 15 to 16 members already paid fees here. Yes, thanks for paying fees and joining into my batch. Okay, almost 15 to 16 members paid. Yes, I think maybe 2 or 3 members were left. Okay, yes. Yeah, that's all for today. Yes, we'll continue tomorrow. Yes, going forward, we'll be enjoying a lot. Yes, every day by day, increasing interest. Day by day, increasing your interest in my classes. Most of the trainers day by day decreasing interest, but my classes. Yes, every day you will see some new thing, something learned, something learned. Yes, very interesting. Every day you'll see interesting classes. Okay. Yeah, that's all for today. So thank you guys. Thank you guys. Yes, any doubts? Yes, guys, any doubts? Yes, any doubts? If no doubts, let us wind up session for today. Let us wind up. Okay. Yes, tomorrow also same link, same time. Thank you guys. Yes. Shiv Teja. Yeah, definitely. Definitely. Yes, sir. Definitely. I will do it. Definitely. Okay. Yes. Yes. 1 second. I think you are in WhatsApp group. Yes, Shivatesha. Are in WhatsApp group? Okay, fine. Yeah, yeah, that's okay. Mr. Abdul Samad, okay, fine, fine, you can do it. Fine. Abdul Samad Mahmad, fine, you can do it. No, no, no chance. No chance. No chance. Okay. Yes, you can ping me. Yes, in WhatsApp. Okay, you need that kind of information, you can ping me in WhatsApp. Yes, I can talk to you. You can call me also. You can call me also. Thank you.